The universe is a vast cosmic ocean, and sometimes a rare visitor from another star system sails into our view. Right now, that visitor is 3I/Atlas, an interstellar object, a true messenger from a distant sun. This isn't just another rock, it's only the third confirmed interstellar object after Oumuamua and 2I/Borisov. We believe it's a comet, a dirty snowball of ice, dust, and rock, carrying secrets from its home system. As it nears our sun, its ices vaporize, creating a glowing coma and a magnificent tail. Why the excitement? Because 3I/Atlas is a time capsule, holding the chemical fingerprint of its birthplace. By studying it, we glimpse the building blocks of planets from another part of the galaxy. We can't travel to other stars, but sometimes, pieces of them come to us. Every photon from this comet is a page from a book we've never read. Tracked by telescopes like Atlas, its journey has just reached its most dramatic chapter, crossing Mars's orbit for a close-up look. The scientific community is watching closely, as this fleeting visitor is already challenging our ideas about comets. The cosmos always has new lessons, and 3I/Atlas is its latest, most spectacular professor. This is more than a comet. It's a cosmic messenger, and we are its privileged audience. Let's dive into its story. Imagine a journey lasting billions of years. 3I/Atlas was ejected from its home system, flung into the interstellar void. For eons it drifted alone, passing countless stars, until it wandered into our sun's domain. Its path is hyperbolic, too fast to be captured on a one-way trip through our solar system. This gives us a single precious chance to study it. As it fell inward, it crossed the orbits of the giant planets, awakening as it neared the sun. Frozen for ages, its ices began to sublimate, turning directly into gas and forming a coma and tail. This transformation is one of the cosmos's most beautiful spectacles. Now, it's just past Mars's orbit, close enough for our best telescopes and Martian orbiters to observe. We're witnessing it in a state of rapid change, capturing a snapshot of this ancient traveler. The data we collect now is a once-in-a-lifetime opportunity. Its long road has led it here, to our front door. We're ready to learn all we can from this cosmic wanderer. The journey is fleeting, but the discoveries could last forever. When 3I/Atlas crossed Mars's path, it created a rare alignment. Our Martian orbiters became comet chasers. Probes like Mars Reconnaissance Orbiter and MAVEN turned their instruments from Mars to this interstellar guest. For scientists, it was a high-stakes, around-the-clock operation. Commands had to be timed perfectly. These spacecraft, not designed for comet study, offered a unique, undistorted view from Mars's orbit. As data streamed back, each image and spectrum was a piece of a never-before-seen puzzle. We were witnessing, for the first time, the details of a visitor from another star system, as seen from another world. From Mars, we could study how the solar wind interacted with the comet's atmosphere and analyze its chemistry with unprecedented clarity. This wasn't just a flyby. It was a scientific ambush, and we were ready. The Martian encounter gave us a perspective impossible from Earth. It was a moment of pure discovery, fueling our passion for exploration. The universe had handed us a golden opportunity, and we seized it. NASA and observatories worldwide launched an all-out campaign to observe 3I/Atlas. Hubble focused on its core, while the James Webb Space Telescope analyzed its heat and chemistry. The first data stunned scientists. 3I/Atlas wasn't following the usual comet rules. Instead of water ice, its spectrum revealed enormous amounts of exotic ices. The familiar water signature was weak. Something new was dominating. This comet was fundamentally different from any we'd seen, even other interstellar visitors. The shock quickly turned to excitement. Every check confirmed the results. Science thrives on the unexpected, and this was a revelation. NASA's gaze had uncovered not just a new object, but a new kind of object. Our models were challenged, and our understanding of comets was forever changed. The universe had surprised us once again. The most stunning discovery. 3I/Atlas is rich in frozen nitrogen and carbon monoxide, not water ice. These ices are common only in the coldest, most distant solar system objects. Finding them here is astonishing. This explains the comet's early activity and incredible brightness. It turned on far from the sun. The comet is hyperactive, its exotic chemistry fueling a massive, brilliant coma. Hubble images show it's fragmenting, its nucleus is breaking apart, likely from the violent sublimation of its volatile ices. We're watching a comet self-destruct before our eyes. Its trajectory is interstellar, but its composition is like something from the outermost reaches of a planetary system. Maybe it formed in a region far colder than our Kuiper Belt, or it's a fragment of an icy dwarf planet. The possibilities are vast and thrilling. This is a tale of two comets, one from another star, but with chemistry that rewrites our expectations. 3I Atlas is a cosmic enigma, and we're just beginning to understand it. The data is clear. 3I Atlas's spectrum is dominated by molecular nitrogen, frozen solid. This suggests it formed where nitrogen ice was more abundant than water, a profound clue about its home system. Mars orbiters detected its massive gas cloud interacting with the solar wind, creating a bow wave on a cosmic scale. The comet's coma is enormous, far larger than any local comet at a similar distance. James Webb's thermal imaging showed its surface is still incredibly cold, likely due to nitrogen frost boiling off and cooling it. This comet is sweating nitrogen, keeping its core in a deep freeze. Tracking its path and the rocket effect of its jets lets us trace its journey back toward a young stellar association. 3. Atlas may be a remnant from the chaotic birth of planets around a young sun. We're doing interstellar archaeology, uncovering the history of another star system, one comet at a time. The story is written in starlight, and we're learning to read it. 3I Atlas forces us to rethink what a comet can be. For centuries we assumed our comets were the template. Now we know nature's cookbook is far more diverse. This is a new class, a nitrogen comet, born from a different environment. Its discovery changes how we think about planet formation. If some systems make nitrogen-rich comets, their planets could be very different. Could there be worlds with thick nitrogen atmospheres, or even nitrogen oceans? This energizes the search for more interstellar objects. Now we know to look for the strange and unexpected. Future telescopes like the Vera Rubin Observatory will scan the sky for more of these messengers. If our third interstellar object is this different, the diversity across the galaxy must be immense. Oumuamua was rocky, Borisov was familiar, and 3I Atlas is something else entirely. Each is a new language in the galactic library. The story of planetary systems is more complex than we ever imagined. 3I Atlas is just the beginning. The flyby of Mars gave planetary science an unexpected bonus. The comet's nitrogen-rich coma interacted with Mars's thin atmosphere, creating a real-world experiment in atmospheric loss. MAVEN's data may help us understand how Mars lost its ancient, thicker atmosphere. The comet's gas cloud acted like a fast-forward simulation of atmospheric escape. There's even a chance that a tiny bit of interstellar dust settled on Mars. Future missions might find it. This encounter shows how planets and cosmic visitors are interconnected. The story of Mars is written not just in its rocks, but in the celestial events that shape it. 3I Atlas is now racing toward the sun. Will it survive, or disintegrate in a final burst of activity? Either way, science wins. We'll learn about its composition, structure, and fate. This discovery proves the power of curiosity and exploration. We found a nitrogen-dominated interstellar comet because we dared to look. Every new telescope brings surprises that challenge our understanding. These cosmic messengers are direct samples from other planetary systems. One day we may send probes to intercept them, but for now, our telescopes are our starships. Each interstellar object is a new chapter in the galactic story. We'll keep watching, keep searching, and keep learning, because the universe is filled with wonders we haven't even dreamed of yet. The journey of discovery never ends.